We're going to finish out this section by taking a look at an idea of a factorial and how to simplify expressions involving factorials. Factorial, containing the word factor, is a descending product of integers starting at n going down to 1. And so the technical definition of a factorial is that n factorial is equal to n times n minus 1 times n minus 2 times n minus 3 all the way down to 1. So a very simplistic example of evaluating a factorial is 5 factorial. And 5 factorial is 5 times 4 times 3 times 2 times 1. And we know that this is going to be 20 times 3, which is 60, times 2, which is 120, times 1. So 5 factorial is 120. Pretty easy. In an expression like 18 factorial over 16 factorial, it would certainly not be advantageous for us to multiply 18 times 17 times 16 all the way down to 1, and then multiply 16 times 15 times 14 all the way down to 1, and then simplify it. A little bit easier way might be to write out the factors that constitute each of the factorials. So 18 factorial is 18 times 17 times 16 times 15 times 3 times 2 times 1. 16 factorial is 16 times 15 times 14 times 3, 2, 1. And notice that 18 factorial actually contains all of the terms or all the factors of 16 factorial. And so when we simplify this, we're really just left with 18 times 17. And 18 times 17, 17 square. We can just go ahead and do this out. So that's going to be 56 and 126 and 18. It's going to be 306. All right. So that's a pretty easy way for us to be able to evaluate these sort of factorials. Right? Now, what if it's just a variable expression? So we have n plus 4 factorial over n plus 2. Well, we know that we're just going in multiplying in descending order according to integers. So n plus 4 factorial is n plus 4, n plus 3, n plus 2, all the way down to 3, 2, 1. And n plus 2 factorial is n plus 2 times n plus 1, all the way down to 3, 2, 1. And notice that similar to above, everything's going to cancel out except for n plus 4 times n plus 3, which is going to be n squared plus 4n plus 3n plus 12, or n squared plus 7n plus 12. And then finally, one final example is n squared or n factorial over n minus 2 factorial. And so we can write the numerator as n, n minus 1, n minus 2, n minus 3, all the way down to 3 times 2 times 1. And then n minus 2 can be written as n minus 2 times n minus 3, all the way down to 3, 2, 1. And so what we're left with is we're left with n times n minus 1, or n squared minus n. Right. So that's how we can work with factorials and simplify them. And we're going to need to make sure that we can work with factorials as well as sequences and series when we start our next section, which is going to be induction by using proof by using mathematical induction.